Okay, so in today's session, we'll be discussing about one of the important topic in electric vehicle, that is actually a cell balancing. Okay. So we will build the simulation model for the cell balancing. Okay, let's keep it very simple. Okay, actually, what is a cell balancing? Okay, to understand cell balancing, we have to first understand. Okay, what is cell imbalance? Okay, so I will just make the topic cell imbalance. Okay, so first we have to understand the cell imbalancing, then we have to understand cell balancing. So actually, what is the condition? Suppose we have, let's say, three cells. It will be not three cells in real time. It may be 64, 65, based upon the requirement of the motor. Okay. For example, Mahindra Electric, they are using 64 cells. Tata will use different. Okay. So such a way the electric vehicle manufacturing companies will use number of cells in series and parallel. So what I am taking, let's say we have a three cells. Okay, it may be series or parallel connection, or it may be the combination of both series and parallel. So as of now, let's say the first cell is 70% charged, second is 60% charged, third is 40% charged. This is actually the cell imbalance condition. The SOC of the cells are not equal. Okay, so because of the battery internal chemistry, okay, with the continuous use, the cells SOCs are not equal. See, for a final battery pack, we should have one main SOC. If this is a battery pack of three cells, okay, the final SOC. Can you say what is the final SOC? No, because the SOCs are different. Correct? No. This is a final battery pack with a positive and negative. It contains three cells, maybe in parallel all series parallel, whatever. It may contain 64, 100, 120 cells, whatever. Can you tell the final SOC of battery pack? Can you tell it 70, 60 or 40? No. We don't have any final number to say for the final battery pack. Why? Because the first cell is 70, second is 60, third is 40. So in this condition, what we have to do? We have to balance the cell. Then only you can connect the load or charger, whatever. You have a final positive and negative, so you can connect a load also, and you can connect the charger also. Both you can connect, but not in this condition. Cells has to be balanced. That means either all should go to 70, okay, or all should go to 60, or all cells should go to 40. So the process of balancing the SOCs of the cells is called as cell balancing. Okay, so now I will remove the imbalance word. You can understand. Okay, so what we have to do? We have to make all the three SOCs equal. Then only you can connect the load and charger. Remember, in electric vehicle industry, okay, we can't connect the load or charger with the unequal SOCs. We have to make the SOCs equal. That's the confirm thing. Okay, the process of making equal we call it as cell balancing. Actually, we have two method of cell balancing. One is the active cell balancing, ACB I am writing for active, and one is the PCB, that is the passive cell balancing. PCB, passive cell balancing. See, I will discuss about the ACB later in the next video, okay, or maybe the another video. But generally, for 99% of the case, we use the passive cell balancing. Okay, so first understand what is the passive cell balancing, then you can pass in the comment box. Okay, what you think about the active cell balancing. Electric vehicle industry go for the passive cell balancing. Okay, so we have to first understand the PCB, that means the passive cell balancing, and then we have to build the simulation model for the same. This is our task for the today's session. Okay, so how to balance the cell with the PCB? Actually, the minimum SOCs will be the reference. What is the minimum SOC? 40%. This will count as a reference. All the other cells has to reach 40%. 60% cell has to reach 40%, 70% has to reach 40%. But the condition is that, what is the condition? You can't share the charge. What is the condition? Condition is that you can't share the charge. Sharing is not allowed for the PCB. You can't share the charge. That's the thumb rule for the PCB. If you can't share the charge, you have only one way to reduce the SOC. You have to minus the SOC percentage. Correct? No. That means 40% you have to minus, sorry, 30% you have to minus from cell A, 20% you have to minus from cell B, middle one. Cell C you can keep idle. Correct? This 30% is the power wasting. 70 minus 30 is 40. This 20% is the power wasting. 40 you have to keep as idle. So this wasting of power is done by the resistor. How to waste power in DC circuit? Resistor. Okay. And these resistors, resistance, whatever you called, they are called as a power dissipating resistor. Power dissipating resistor. DR. Okay, so hope you understand. Okay, the theoretical stuff. So we have three cells. Let me repeat quickly: 70, 60, and 40. Okay, we are going for the PCB. We can't share the power, or you can say the energy, or you can say the SOC. So the minimum will count as a reference. So 40% is the reference. So I have to remove 30% from the cell A, 20% from cell B, and C has to be idle. So that power 30% waste or 20% waste we have to do by the power dissipating resistor. So this is the way to do. Let's build this in the simulating. The only you can understand. Okay, the process of the simulation. Okay, so same theoretical thing we have to implement in the simulation. That's what is the beauty of electric vehicle industry, electric vehicle training. Okay, it's the cumulation of the, you can understand, accumulation of the theoretical and the software. So first understand the logic and then implement. Okay, logic is simple. We have to take three cells with different SOC, and then we have to connect the power dissipating resistor. This is the task for the today's session, today video. Okay, so let's do that thing. Okay, so hope you are not familiar with some of the terms of the simulation, how to take a battery block and that thing. Okay, so let's do the simulation. Let's go to simulation. If you go to simulation, actually I have built the model, you can understand. Anyway, I'll build from the scratch. Okay, you can see I took a three cells connected in parallel. Okay, and then the resistor, that is the power dissipating. One MATLAB function I have to use. Why? Because I have to give the instruction. Let's build from scratch. You will understand. You can ignore this model as of now. We will build it from scratch so that you can follow very easily. Okay, so let's take a fresh file and its name as a you can save the model as a passive cell balancing. Okay, it is we discussed that we can't save the name with the hyphen, so better you type here passive underscore cell underscore balancing. This is the way how you can do. Okay, so let's proceed. Okay, so you can name something. I mean to say, paddle it's open now. So let's increase the cell L to 3. It will take. Okay, so passive cell balancing you have to do. Correct. So let's take a 3 cells. You can take in series and parallel. Okay, actually we have to take in series. Why? Because in series the voltage varies. Okay, in a parallel actually the voltage remains same. This is the basic law of the electrical engineering. If you are connecting something in series, the voltage will increase. Okay, and if the voltage is increasing, that means the SOC will change. So SOC change is only possible when you have the cells connected in series. It is not possible in parallel. If you are going for a parallel connection, voltage will remain same. The current will vary, right? So in this condition, the SOC won't change. So actually, I have to connect the cells in series. Remember this thing, students, and whoever is watching the video, you should know that thing. Keep in mind, cells connected in series only are eligible for the balancing. Because why? Because the voltage will increase when the cells are in series. So SOC will change only when the cells are in series. Okay, so in a parallel, there is no chance of the SOC to get changes. Okay, so you have to connect the cells in series. Remember, no parallel connections. Take 3 cells, let's say battery. Okay, and name as a cell 1, cell 2, and cell 3. These 3 are the cells that are connected in. I have to connect in series. So how to connect in series? Negative to positive, negative to positive. Simple. See. So as per the concept only we are going. We took 3 cells now on a whiteboard. A, B, and C. So it kept in horizontal. In a model we kept vertical. I told you that arrangement doesn't matter. Okay. You can keep the cells in vertical and also make the series connection. That doesn't matter. Cell B, cell C. Yeah, SOC has to be varied, right? We discussed the first one is let's say 70%. Leave the other thing to default 70%. Second one we kept I think 60%. So you can double click on any of the block, change the block parameter to 60%. And the bottom one is let's say 40%. Okay. Now we have to go for the uh, what is the next step if you see on a whiteboard that resistance, that is the power dissipating resistor. Okay, so each cell will contain that resistor. Even the cell C we have to connect that, but will be not using for cell C. We will program in such a way. Why? Because cell C is already 40. That's a reference. Okay, so for each cell a resistor is required. Correct. So how to take it? We discussed in last video. Series RLC branch. Take a series RLC branch. Okay, make it resistance R. If you are comfortable, just uncheck the name. Okay, because as of now you understood the block name. Yes, this is for the first, second, and third. Yeah, you can press all, select all, also press Control R to revert. See, 1, 2, and 3. See, for each cell we will have one power dissipating resistor. We discuss in theory as of now. Initially, for each cell a power dissipating resistor. Perfect. Right? But when to turn on and when to turn off, the instruction has to be given via switch. Okay, so because you can't turn it on every time the same resistor, right? So to give some instruction, ideal switch or MOSFET or IGBT, anything you can take. Let's take as ideal switch. Okay, so this M is not required now. M is the measurement port. Uncheck the measurement port. Okay, now connect positive to 1, 2 to resistor, close to negative. Correct now. Again drag and drop. Again positive to 1, 2 to resistor, this to negative. Same thing we have to do in the bottom cell. So imagine if you have number of cells 16 in series, you have to make the 16 circuit like this. Positive to plus, 2 to here, negative to here. See, done. Instruction we have to set actually. That can be done by the MATLAB function. Resistance value you can keep as of 1 because we are making the base model itself. Yes. Now we have to measure the SOC. So how to measure that, you know, we discussed in last video. Just go to my all videos, from it is arranged in serial number, you can understand. It started from the base only. So it's starting from the base and slowly I will try to load with the big model. So first model we did was a battery pack. Okay, series panel. Second model we did was a cutoff charging circuit. Third model we did was a cutoff discharging circuit. Fourth model we are doing is a passive cell. So come by the serial number sequence you follow. First go to battery pack videos, then go to cutoff charging, then go to cutoff discharging, and then go to PCB. You'll understand. Okay, you can learn the electric vehicle free of cost. No need to go anywhere. Okay, anybody can access from anywhere. Right. In the fifth, we'll go for let's say SOC estimation. So videos are in synchronized way. Okay, active cell will take later because that is not used so much, but still I will take that session also. Yes, so I was discussing how to take the, I told you no, in the initial video, you can't directly measure the measurement port. You have to take the bus selector. Take bus selector. Okay, and simply connect to the measurement port. It is taking some time to load. Don't disturb because it is showing BG. Okay. So once the block comes, then you can easily drag and drop. Okay. The bus selector came. So you have to connect to the cell A, right? So press Control I to make this side input. And initially for a few sessions, it is hard request to, I mean to say, click the block name because you will be remembering the block name in this way. Okay, so click on a three dot, so block name. Copy. But before creating the copy, make sure what we are going to select. Double click on that. I want only SOC, right? So I will remove signal 1, signal 2, SOC only I want. Apply. Okay. See. Okay, so before creating copy, if you can select the signal, that's a good thing, no? Because you don't have to again create. See, already SOC is filled there, so that is also possible. If you create a copy first, you have to again select SOC in every bus selector. One repetition block name, avoid it. because you understood the name the bus selector, it is not required to give the name for the copied blocks. See, correct. Now this will give me the SOC of the first cell, second cell, and third cell. Right. If you want to see, I told you you can connect a display. Okay, because SOC will be coming after the cell balancing. It will be constant value. You can use the display. So press Ctrl I to reverse. If you use this display, what will happen? Display is a block that is used to visualize the output. If you connect like this, okay, so what is happening in this case? You have to connect three display. Why? Because first for the SOC 1, second, and third. Okay, this will increase my model length. So what you can do, we have one block, extra block, I am telling in today's session, that is the mux block. Mux means multiplier input, multiple input, one output. See, it looks like a bus selector. That's why I'm telling you initial few session. Please observe on the block name. It's a bus select mux. How many input I want? Three. One three input. Press apply. Press OK. Select on it and reverse it. Press Ctrl I to reverse. And how many input we have to give? You can increase the size of the block also. Three input. Okay, we want to see on in one display itself. So multiple input, one output. Multiple input number second, multiple input number third. Correct. Connect a display, connect like this. See, it will give the SOC of all three cells. This is the model. But okay, if you run it right now, it is not a proper logical. Why? Because we haven't gave any instruction to the switch. Okay, to give instruction to switch, we have to little bit programmed it. So mechanical engineer, please don't panic by the programming. It's not so much difficult program. It's just a basic program. So that I have to write. Okay. So while writing only, I'll make you understand that programming. It's very much normal. Okay. So let's build a program. Why programming we are doing? Because I have to tell the software when to turn on this first number, when to turn on this second number, when to turn on this third number. So for that purpose, I am going to program one logic. Okay, let's do. So take a MATLAB function. Okay, yes. So go inside that MATLAB function is a block that is used to give certain instruction in a programmed way. If you go inside, something is mentioned automatically, remove that. By default, it will be mentioned something. Okay, just wait for a few seconds. Yes, we have to remove because I want to type my own syntax. So what I am typing, let's say function, uh, type in actually small letter function. Okay, see what I wrote, s1, s2, s3. Okay, is equal to fcn. This should be in middle bracket, sorry, small bracket, u1, u2, u3. Actually it should come inside, so press Ctrl X and go inside Ctrl V. So what it will do, it will actually create one input and output relation, right? What is the relation? So it will create one logic like this. We have a function h1, h2, h3. So here will be u1, u2, u3, and this side will be S1, S2 and S3, like this. So this S1, S2, S3 is depending upon the U1, U2, U3. That's what the statement shows. Okay, so basically I will just copy down the code. That will be more better, I think so. Okay, to make you understand, because it will take a time for writing. So see, this is the thing. Okay, you can see here it gives a green color symbol. That means now everything is okay. So u1 is equal to integer 30. That is just a data type conversion to work in decimal format. We don't want to work in 0 and 1 format. Why? Because SOC will be not in 0 and 1, it will be 70, 80 like that. Okay. So if U1 means SOC 1, if first number is more than second number, we have three cells, right? So first SOC is more than second and first is more than third. Then turn on the first number switch. Else or turn it off. That means that, okay, simple, it's simple. If you go back to the model, you can understand. Okay, first one is the S1. That means this is the S1 actually. This is S1. Okay, this is S2. Okay, this is S3. So when S1 should turn on, I mentioned in the programming. When the first number is more than the second and third. Similarly, when second is more than first and third, second should turn on. When third number is more than first and second, third should turn on. Simple. Okay, so this is the function we have to build, and u1, u2, u3 is the SOCs. That means it is something that we have to connect to SOC. So don't panic by seeing the MATLAB function. It's simple only. Just go through my videos again and again, you will understand. And just ping me or comment if you have any doubt. Go to format, go to, you can give the color also. Let's say this is, I'm giving as a blue color. Now understand, see. So u1 should go to SOC1. Why? Because I gave the instruction in such a way. U1 means SOC1. Okay. So U1 should go to SOC1. U2 should go to SOC2. U3 should go to SOC3. Simple. Don't panic by seeing the lines. It's just a logic. S1 should go to first number switch. S2 should go to second number switch. S3 should go to third number switch. That's all. Okay, press space to fit the screen. If you want, you can give some color to the resistance. For example, right click format. There are two options: foreground color, background color. Foreground means how I did the coloring for the MATLAB function. Background, see, if I do the background red, it will be completely red from background, like a word format, right? Similarly, right click, go to format, go to background color, give it red. See, right? If you give the foreground color, it will be only from the foreground. Go to format, foreground color, give it red. See, this way you can give some logical color. This way you can give some technical color. Okay, so the model is ready to be simulated. One more thing, you require the power GUI for the simulation. So take a power GUI. That's the compulsory solver. Take power GUI, turn it on. Right click, show block name. Sorry, format, foreground color. Make some color like a magenta, whatever you want. Okay. Not compulsory, but you can decorate. See, the perfectly built passive cell balancing model. So you can work on some model like I did for 3 cells in series. You can make a battery pack of 7 cells in series. You can make for the, let's say you can make for a 4 P60. That will be different on a next level. If you can build, you can try at your home and pass a comment to me whether you are able to do or not. In 4P16s, the parallel is not required, only the series is required. So 16 cells you have to connect, right? That's the logic. Okay, so let's run this. So definitely I'll be getting all the cells SOCs equal. Why? Because we did the balancing part. So if you run it, you can see in the display three SOCs. Okay, don't disturb while software is running. Okay, so it's compiling, then you can see because the model is big, it is taking some time, else it will not take so much time. So similarly, you can go for the active cell balancing. Okay, based upon the logic. Their logic is something different. Okay, so that's why I thought of taking in the upcoming session. Okay, you can comment, you can ask any doubt via comment. I'll be happy to help you. See, the first one is went to 69.61, second one 59.61, third 140. Why? Because we have to give some more time. We only gave here 10 seconds, right? At 10 seconds is not enough for the cells to reach at 40%. So we have to give some time. So how to keep that time? Increase the stop time, right? So just to wait that option to be get enabled, then we can give that time. Okay, so when you are building a big model, please keep patience. Okay, because it will uh, lag some time that you have to keep in mind. Okay, so just to wait for the options to come. Okay, or else I think the grade option is still there. You can try this model. Okay, just change this time to maybe 1 hour, and or you change it, you will be seeing here 40 and 40, all three 40. If you are not getting, you can ping me via comment. All three should come 40. Just you have to change the stop time to 3600. Okay, simple. Okay, so hope you can build this model. It's a passive cell balancing. You can name it here. Double click, name passive cell balancing. So a lot of models are there. Okay, it's a complete 1 hour course. Not 1 hour, sorry, it's a 1 year. Okay, so if you are spending each day one model, complete it. Especially the students who are in second and third year or final year students, for them it's very much beneficial. Okay, so spend 2 hours per day out of the college. Okay, and then you can easily learn this thing. Okay, so if you watch 2 hours, build a model, run it. Okay, and keep it in your laptop so that when you pass, you have one skill set to mention. That is the electric vehicle. Okay, so meet you in next video.